Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of substitution by matching. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Now we want to start through the steps. The first step is to set u equal to the expression raised to the power. Now if you have any doubt about what u should be, I'll give you a little tip that's especially useful in the beginning here with these types of problems as you're learning. Later on I think it'll become second nature, but here's the tip. If you're ever in doubt about what u should be, choose u to be the expression with the highest power. So for this particular problem, you've got an expression that could be u, maybe the 2x cubed plus 4x. You've also got the expression 3x squared plus 2. But 3 is higher than 2, so I would suggest, according to that tip, to choose u to be the expression with the higher power. 3 is bigger than 2, so I'm going to let u be 2x cubed plus 4x. Later on, as you build intuition, you won't have to formally think about this so much, and as you get to more complicated problems, you'll be able to figure out a way to avoid having to even think about this tip. But right now, I think it's very useful. Then you go to step 2, which is to compute du dx. That's the derivative of u with respect to x. That's 6x squared plus 4. Of course, the goal is to solve for du, which is what step 3 says to do. So you want to multiply both sides of the equation by dx. The dx's on the left cancel out, and you're left with du equals the quantity 6x squared plus 4 multiplied by dx. Now, anytime you see a differential that has a common factor in it, it's probably a good idea to factor it out, and you'll see why in a minute. And if you don't need it factored out, you can always go back to the form of du which doesn't have it factored out. But as a matter of course, that's usually going to be what's required. So I noticed that both the 6 and the 4 have a 2 as a common factor. So I'm going to factor the 2 out of there. And that leaves me with 2 times the quantity 3x squared plus 2 all times dx. Now you can kind of see why that probably was a wise idea, because if you look back at the original integrand, you'll see a 3x squared plus 2 in it. And had you not factored the 2 out of the 6x squared plus 4, you might not have noticed that. You'll get better at this as you do more of these problems and practice more and more. Step 4 says if the integrand has a numeric, just a constant factor, in other words a number, as a factor, move it outside the integral. There aren't any numeric factors in this one, so you don't have to worry about step 4. Step 5 is probably the step that you have to give the most work to get through it. But it says reconstruct the integrand so that the u part is followed by the du part, remembering that we can compensate by a constant factor if needed. Now all that really means is you're going to let your u part come right after the integral sign, and you want all of your du part to be at the end of the integral. And if you don't get an exact match with the differential you just calculated down here in the lower left corner, then you have to make that adjustment by a constant factor. And so let's look at that. The first part, the thing that you called u, that whole power, u to the power, that's what I'll call the u part, and it comes right after the integral sign. Everything else comes to the end and becomes part of the du. So the u part will also include the exponent. So u is the expression 2x cubed plus 4x, but when I say the u part, I'm also including the exponent. And like I said, the du part is everything else, and you want it to be at the end of the integral. Now we're set up perfectly to finish this problem off, but the key to knowing whether in this step 5 that you need to compensate by a constant factor is looking at this differential in the lower left corner and seeing if it's an exact match already. And what you'll notice is it's almost an exact match. There's a dx in both. There's a quantity 3x squared plus 2 in both. But the integrand does not have that 2 that we need. So you need to look at what's missing. There's a constant factor 2 that's missing, and you can put it in there. And what I'll do here is I'll just space it out a little bit so I've actually got room to put the 2 in there. Once I make a little room, I'll just put the 2 in there. But you can't just put the 2 in. You have to compensate by multiplying by the reciprocal on the outside, and the reciprocal of 2 is 1/2. Don't forget that. That's important. So where do we stand? Look at what we've done. The u part is the part right after the integral sign. The rest of it is the du part. Now the question is everything completely matched? Well, let's see. Don't forget also that you have to keep copying that 1/2 down, even though you're not doing anything with it right now. You do have to copy it down. The u part is perfect. It's going to be the expression 2x cubed plus 4x is the u, so it's going to be u, and it's raised to the 3rd power. That's perfect. But look at the du part. Because I put that 2 in there, it's now an exact match. Looking in the lower left corner, it's an exact match for what we're calling du. And the goal is, the original problem is full of x's and a dx. When you finish your substitution, there should be no x's or dx's. There should only be u's and du's. And that's what we have here. So to continue, copying that 1/2 down, we are now ready to evaluate that integral. And we know how to integrate u to a power because we have the general power rule for integration. And it says you can integrate u to a power and you end up with one higher power. In this case, the 3 goes to a 4. But you also have to multiply by the reciprocal of that new power. The reciprocal of 4 is 1/4. Don't forget that. Also, don't forget that for an indefinite integral, any indefinite integral, you have to have a plus c. Now we can tidy things up a bit. 1/2 times 1/4 is 1/8. So you have 1/8 times u to the 4th plus c. We're sort of running out of room, so let's move that expression up top so we can continue. And the only thing left to do is to get rid of the u. Remember, we put the u in there. There was no u in there in the beginning. So we go back and replace u with 2x cubed plus 4x. And there you have it. And keep in mind, if you have any doubt that you got the answer right, all you have to do is take the derivative of what I've just boxed in there and convince yourself when you take its derivative, you get what you started with. You can always check these integrals by differentiating and see if you get what you started with. So if you end up with that answer, differentiate it and see if you get back the integrand that you started with. If you do, you know you got your integral right. In any case, there's your answer.